human beings are made, evolved, in such a way that they have questions. They want to learn about surroundings.
The pursuit of knowledge has been an endeavor of man since recorded history.
During this, even last century and this century, science had become a dominant force. Understanding of the world and of ourselves has been so much improved.
What it is that allows biology to build something as marvelous as a brain.
What science is all about, the excitement, the curiosity that we all feel about being scientists, because there is no other road for us than to try to make discoveries, to understand nature. I like to make clear that we all are basic scientists. We believe that in order to understand how the brain works, you need to do basic science, to understand the way the brain is constructed, from genes to molecules to circuitry and to cognition, all the way to the understanding of our behavior.
I was the first in my family to go to college. My father is son of a Greek immigrant in the U.S. And I actually wasn't even planning to go to college, but at the last minute I decided. I went to the University of Colorado. And there I became inspired by science. I started a graduate program interested in understanding gene regulation, how genes are switched on and off.
My father was a psychiatrist. I grew up in a mental hospital where my father was in charge of. So I grew up my life with people who were mentally ill. That's the reason why I, having grown up in this environment, seeing the people and understanding them, how it was to be in the suffering, that I wanted to understand how the brain worked. And so I went to medical school, and then I find that the treatment that was existing at that time was not adequate. It really didn't have the result that I wanted to see with patients. So I decided I would do science.
This is about reliability or unreliability of memory. Now, I'm not sure how much you are aware of this, but in daily behavior, actually, almost everything you do is guided by the memory you have stored in your brain. Okay? You should say this, or you should not say it. I should go there or not to go there. I should eat, not to eat. Everything, all of this, is you are guided by the information you stored in their memory.
I was invited to Hopkins, and the research that the person who invited me was doing has to do with the eye and the retina. So I spent the 40 years, next 40 years in the lab, looking at the eye and how the eye then talks to the brain and how the brain analyzes the images that fall on my retina. I found the problem to understand how the retina works and how images and how can we see things in detail and color and so on. How is it done?
Now, neuroscience, as I've been telling you, we are studying what's going on in this brain, nervous system, particularly in human brain. So, if you think about it, everything what's going on, whether it's science or art or politics or economy, is actually the product of what's going on in here, human brain.
For the past 25 years, 30 years, we've been trying to understand how our senses capture the world. But there's a problem. The world is made of real things, but the brain is only made of neurons and electrical signals. So how do you translate the real into an internal representation?
This is actually an experiment that David and I did together, and this is a process. We map the receptive field, this area the cell can see, in this very simple procedure. See, the cell response, both direction of movement, actually prefers the left a little bit more. This is now the critical point. So the same receptors are being stimulated by this power light, but this cell can't see that this cell. It's only when the bar is oriented close to vertical that the cell. That's amazing. Nature is amazing. Nature has secrets.
The system is not like a fax machine that an image is fall and then sent up as an image to the brain with little people sitting up the brain looking at this picture. The picture is completely taken apart and then sent up pieces of it and then assembled again in the brain. The reason why my colleague David Nobel and I got the Nobel Prize was because people said we broke a code that made it possible, or one of the mechanisms used by the brain to put things together.
Yeah, you know, I think that what was really important in that transition is having the objective of a deep understanding of mechanism. It was really based on a deep-seated desire to really understand how the cell works, how genes are switched on and off during development, how they're switched on and off during disease. It's not, just an abstract thing where you decide that you're going to clone genes or whatever. It's really trying to develop the tools to answer an important question.
When somebody make a great discovery, you know how we praise it? What word we use? We say, it's beautiful. That's what we say. That's beautiful. Because what we are doing in science and what we are doing in music, what we are doing in painting, it's the same. We are doing the same thing. That is what is called creativity. Create something.
Right now in science, in neuroscience, for a very long time, maybe 50 years, we've been able to understand the activity of individual nerve cells. But in a human brain, there are billions of individual nerve cells. So what we really want to be able to understand is how groups of neurons transfer and transform information, and how information flows rapidly back and forth between the brain. Because the brain is a system where many, many neurons work together. And what we would like to understand is what the logic is that allows those groups of active nerve cells to create this knowledge and to transmit it through the brain. Sometimes people say things like, well, maybe the human brain will never be smart enough to understand the human brain. And even if that's true, I think we are so far from that point that we still have a lot to learn until we hit that wall.
The world changes. The world changes as a consequence of our knowledge. The way we think, the way we communicate, the global nature of our interactive capabilities are completely different as a consequence of it.
In Chile, the system is not promoting the type of creative, high-risk science that leads to the type of discoveries that transform fields.
And all too often today, what we're observing is that knowledge is no longer viewed as an end unto itself, but rather a means to an end. But to a nation with a sense of itself, with a sense of culture, it seems to me so important that one view an understanding of nature as a primary goal unto itself.